Hello viewers, welcome to my YouTube channel Knowledge and Education Hub. In this lecture module, we will learn about the water forms, water cycle and water balance equation. If you are new on my YouTube channel, please like, subscribe and share. First, we know about the water and their forms. As we know that there are three forms of the water. First is the solid, liquid and vapor. Vapor form is the when the water comes at the 100 degree centigrade, the waters convert into the vapors. Solid is the form of the ice and snow, and liquid is the H2O, that is the running water or stagnant water in the form of river, pond, lakes, groundwater, etc. Water covers 71% of the earth's surface, mostly in sea and oceans. A small portion of water occur as groundwater, that is the 1.7%. In the glacier and the ice caps of Antarctica and Greenland, 1.7%. And in the air as vapor clouds formed of the ice and liquid water suspended in air and precipitation, it is the 0.001%. Ocean, seas and bays is the huge amount of the water, percent of the water, that is the 96.54%. Ice cap and glacier and permanent snow is the 1.74%. Groundwater is the percentage of the groundwater is the 1.69%, and the fresh water is the 0.76%. Saline water is a 0.93%, soil moisture is a 0.001%. This is the for the groundwater, and this is the for the river and etc. River, the percentage of the river is a 0.002, and the biological water is a 0.001%. Water cycle. Before understanding the water cycle, we know about what is the water cycle and how the water cycles comes in our the concept of the water cycle comes in our mind. Earth's water is always in the form of motion, and the natural water cycle, also known as the hydrologic cycle, describe the continuous movement of the water on above and below the surface of the earth. Water is always changing states between liquid, vapor and ice, with these processes happening in the blink of an eye and over millions of years. And from this we consider about a cycle that is known as the water cycle. And a quick summary on the water cycle is: what does all the earth's water come from? Where does all the waters come from? Primordial earth was an incandescent globe made of the magma, but all magma contained water. Water set free by magma began to cool down the earth's atmosphere until it could stay on surface as liquid. Volcanic activity kept and still keeps introducing water in the atmosphere, thus increasing the surface and ground volume of the earth. The water cycle has no starting point, but will begin in the oceans, since that is where most of the earth's water exists. The sun, which drives the water cycle, heats water in the ocean. Some of it evaporates as vapor into the air. Ice and snow can sublimate directly into the water vapor. Rising air currents takes the vapor up into the atmosphere along with water from evapotranspiration, which is water transpired from plants and evaporated from the soil. The vapor rises into the air, where cooler temperature causes it to condense into clouds. Air currents move clouds around the globe. Cloud particles collide, grow and fall out of the sky as precipitation. Some precipitation falls as snow and can accumulate as ice caps and glacier. which can store frozen water for thousands of years. Snowpacks in warmer climates often thaw and melt when spring arrives, and melted water flows over land as snow melt. Most precipitation falls back into the ocean or onto the land, where due to gravity the precipitation flows over the ground as surface runoff. A portion of runoff enters rivers in valleys in the landscape, with stream flow moving water towards the ocean runoff and groundwater seepage, accumulate and are stored as fresh water in lakes. Not all runoff flows into river through those. Much of it soaks into the ground as infiltration. Some water infiltrates deep into the ground and replenishes aquifers, saturated subsurface rocks, which store huge amounts of fresh water for long periods of time. Some infiltration stays close to the land surface and can seep back into the surface water bodies and the ocean as groundwater discharge. And some groundwater finds opening in the land surface and emerges as freshwater springs. Over time, all of this water keeps moving. Some of entered the ocean where the water cycle ends. As we have told you, there is no starting point and there is no ending point of the water cycle. And this is a short summary of the water cycle. And I hope you will understand this. Precipitation is a vital component of how water moves through Earth's water cycle, connecting the ocean, land and atmosphere. Knowing where it is rains, how much it rains, and the character of the falling rain, snow or hail allows scientists to better understand precipitation's impact on streams, rivers, surface runoff and groundwater. And next is the water balance equation. In hydrology, a water balance equation can be used to describe the flow of water in and out of a system. In general, hydrologic cycle is the system which describes the distribution and movement of water between the earth and its atmosphere. Here the P is the precipitation, it is falling down on the earth's surface. Evaporation, which injected into the atmosphere from the earth's surface water. This is the basin, a green periphery line. S is the storage value and R is the surface runoff. Then the water balance equation is described as the P is equal to R plus E plus delta S, where P is the precipitation, E is the evapotranspiration, R is the stream flow or surface runoff, and delta S is a change in storage, bedrock or soil moisture groundwater. And how the factors affecting the water balance equation. A river will always have a regime which they follow. In that some months the discharge of the river will be higher than others. The water balance looks at how the amount of precipitation compares with the water leaving the system as runoff or as evapotranspiration. This balance will change throughout the years and will be affected by the overall climate of the area near to the river. For example, under usual conditions, the precipitation will be matched by runoff and evapotranspiration, giving a normal river level. If evapotranspiration becomes greater for a few months in summer, while precipitation and runoff remain the same, the river will flow below normal level. And that is the key terms to describe the various water balance conditions are. And first, the key terms, water surplus. There is excess water available to the system. This occurs when the precipitation exceeds evapotranspiration and the excess is not being used by plants. Deficiency, which is a reduction of water available within the system. This occurs when the evapotranspiration exceeds precipitation. Recharge, after a period of deficiency, precipitation will occur and replace the lost water in the soil. This needs to occur before a period of surplus can reoccur. Field capacity, the maximum amount of water that soil can hold before it becomes saturated. And these are the terms to understand the water balance equation. First, the water surplus, deficiency, recharge and field capacity. I hope this term you have understood very well. And this is the water balance equation for the saturated zone. Terminology are given here. Delta H is the hydraulic head, and T is the delta T is the time, and Q is the total groundwater inflow and outflow of the unconfined aquifer. And this is the equation for the integrating all three of the water balance: land, surface, unsaturated zone, groundwater, the overall water balance here. And the terminology as given in the just previous slides, where the P is the precipitation, E is the evapotranspiration, E0 and these are the A is the area, and T is the time, and these all terms are well described in the just previous slides. I hope this lecture is very useful to all. If you enjoy this lecture, please like, subscribe and share. Thank you.